So, welcome to the open Q&A session. Thanks so much, Amy. You want to give a quick introduction on yourself and your background, and I can sort of do the same, so people know what's up there and then figure out how this works.
I work at Development Seed. I've been here since early 2018 and mostly standing on the shoulders of giants that work here. But yeah, I've been working mostly with NASA and a group out of Huntsville, NASA Impact Group, on a bunch of their innovative projects. I guess primarily the multi-mission algorithm and analysis platform, which I know Ian mentioned earlier. I've been primarily working on that, spending most of my time on that project the past 3 years or so. And so that project, as well as a new program called Veda, has a strong emphasis on everything cloud native. So while we're using the existing NASA ecosystem of tools, NASA is obviously moving to a lot of cloud native data and data tools. So part of that transition.
Awesome. And yeah, I think the biggest reason I invited Amy is because she knows a lot more about ZAR than I do. Like, I feel like I have the other specs decently covered, but yeah, you have much more extensive ZAR. So I figure between the two of us, we'd be able to answer most questions. Yeah, so I mean, this is the most unstructured session. I think if we don't have any questions, then we can also just cut it short. But I think the main goal is to just give someone structured time, some space where people can ask questions. You know, I think when I set this up, I was imagining the GoToWebinar would serve us better. I think you can try to ask questions through there. There's like some question thing that goes, oh, hey, there's questions. That's funny. I see like a string of questions that probably goes out, short answered questions. And apparently there is much mixture on which of us people can see in Gitter. Like, yeah, so I can only see Chris. Anyways, does anybody have some questions off the bat that you can drop into Gitter? And if not, I feel like we can scroll up and see what open questions people had, and yeah.
So I know one question that comes up a lot is when to use COG versus ZAR. So I was just going to read the thread there from Matt Hansen about the opinion on most Earth observation imagery is best as COGs, while ZAR is good for homogeneous gridded data such as modeled data. And then I think it's Jan asked, are there advantages for ZAR over COG data? I use COG for weather models, but I'm interested in what improvements could ZAR bring. And his lightning talk is in 2 hours. And Matt responded, I think that ZAR is better at modeling multi-dimensional time series together in a single data set, whereas with COGs, you basically can have 3-dimensional data profiles. So you've got lots of variables that better suited for ZAR when data can have arbitrary dimensions, right? So once you're getting beyond XY data variable, it makes sense to maybe use ZAR. Yeah, I'm sure if other people have thoughts on the whole COG versus ZAR debate.
Yeah. I feel like, I was on some session with Development Seed and learned a decent bit on that. And I think, and then dug a bit more. My takeaway, I mean, I sort of start more from COG. And my takeaway was that, yeah, if you're sparser data, COGs tend to be better. I mean, sort of rule of thumb, but like where ZAR really shines is when you have really dense data. And so like most satellite imagery where it's kind of tasked or, slowly collecting stuff, in a monitoring scenario, it's every 10 days or whatever, cog, like the czar advantages don't super shine through. But if you have data that's sort of every day regularly gridded or every month, then it starts to make a lot more sense because it really excels at that time series and that sort of temporal analysis. Whereas cog, you can have like a whole stack of cogs, but it starts to get a bit inefficient. But you don't necessarily always use czar because, yeah, if it's really sparse data, you're not going to have a huge advantage with it. So yeah, I think the line in between that I've seen is, or the kind of gray areas once you get into kind of the analysis ready data and these like regular satellite imagery cubes of data, because they're, yeah, like Planet has our fusion monitoring, or Ian was talking about the HLS, like they're kind of jittering these regular cubes. So that's one where czar can make a lot of difference. But yeah, it seems to depend on the application, what you're going to do with it, what's going to shine more. So I don't think it's a super cut and dry answer between the two. The other cool thing, I think Ryan had been pushing this discovering from the czar perspective, and then Evan has in GDAL has a thing too, where you could also think about each of them as a protocol. So you actually could have a czar server that's backed by cogs or a cog server that's backed by czar, which gets pretty crazy. And it's like, what are these standards really? But yeah, I think speaks to like the fact that there's some use cases where one or the other is clearly better, and kind of communities where they come up, where cogs came up in satellite imagery, czar came up in climate and weather, and these kind of n-dimensional, but then there's a lot of potential overlaps in between. Let's see.
Robin asked a question. I seemed to ask, okay, so can we talk a bit about security in the CNG ecosystem, specifically things like securing services like T-Tyler and Stack Fast API, and also providing item level security for the stack data itself? Any thoughts or comments?
Do you have any experience with that, Aimee?
Well, the thing that comes to mind for the NASA ecosystem is all of the cloud optimized geotiffs that are being produced are, in buckets that are public but require an Earth data login in front of them. So we actually have some folks, I think at least Sean Harkins is involved in implementing, S3 credentials for the T-Tyler itself through like an S3 credential rotation and the Earth data login system. So that's kind of about securing your actual file assets. But he was also asking, yeah, so I'm not sure if that's one solution, right? If like your data files themselves are secured, question is, yeah, is visualizing that data something that your dynamic tiler should still be able to do in front of secured data? Or are you actually trying to protect even the visualization of that data? That I haven't seen done anywhere, right? Where you're basically requiring T-Tyler to accept some sort of authentication token in front of it. And I'm also not familiar with any solutions for securing the metadata itself.
Yeah, I'd be curious. I don't know if Rob or anybody, Tom from Planetary Computers on, but I feel like they have done a bit more than others with some amount of logins, and I think they have a pretty Azure-centric solution. But and I think in answer to your broader question, Robin, like this stuff definitely started with open data, so I think it wasn't a concern. I feel like I just had memories of OGC stuff and just how complicated it gets when you try to really standardize the security stuff. And so I think we've been a little willfully saying, hey, that's outside of the exact scope of the specs. But I think it is one of those next major frontiers. And I know, yeah, Planet is certainly doing more with Stack and starting to look into tokens and different ways to secure it. And we'll definitely, yeah, like Planet's not going to have completely open Stack catalogs of all our data by any means. But I think there's just such a wide variety of scenarios. It could be cool to, yeah, maybe try to get some sessions sometime of people to share experiences. I think in general, at least Stack, and I think a lot of these specs, the way is sort of like, hey, cool, let's give people time to build solutions on them and then share what people did and then kind of see, hey, are a number of us taking similar approaches? Are there bits that we could standardize? Or at least, yeah, what are the chosen paths through different libraries? So yeah, I'd say it's definitely, I mean, back to my first talk, like, I think it's one of those things to make things easier for people, you know, like not everyone can just have open data and not everyone can just work in any environment. So I think having all of us work towards better answers for security and better defaults is definitely a very important thing.
So I think, so Ryan Abernathy mentioned that there is going to be a Czar tutorial tomorrow that might answer a lot of questions about what Czar is good for, but I was wondering, could we make Ryan a panelist right now in case he wanted to say anything?
Probably.
At this particular moment?
Yeah, that'd be great. Yeah, I mean, and I'm all for adding lots of people to say stuff. I was hoping to be easier to do than, but yeah, Jonathan, could you see about adding Ryan? Oh, there we go. I see you. I don't know that you need to present.
I am here.
Hey. Hey, I see you.
Hello.
Hello. So yeah, I think we were just hearing some of your Czar knowledge. I mean, tutorial will cover lots of it, but.
The tutorial is also at a time that might not be convenient for everyone, so we can.
Especially
happy to. Is there like a specific like the cog, when to use cog versus Czar is like a very endless discussion, you know, like, but it is one we should keep having because I just feel like, I mean, what you explained made sense. You know, cog kind of came from the remote sensing, you know, geospatial imagery world. Czar was more using climate and weather and stuff like that. But actually, so many of the cool applications involve bringing those two types of data together, right? So we definitely shouldn't just like stop there. We should work on getting them fully interoperable and mergeable, and ideally Stack can help with that somehow. You know, when comparing cog and Czar, I think it's really important to like also bring Stack into the equation, right? Like this is what we were talking about in the chat. Like if you really want to compare Czar, like you could, how should you store a data cube, right? Like X, Y, and time. Like there's Stack, cog alone doesn't have a great solution to that, but cog plus Stack have a solution to that. And it involves explicitly like enumerating each time step as like a Stack item. In Czar, you can put that entire data structure into a single Czar store. So in many cases where cog also needs Stack to get certain functionality, you can bypass Stack with Czar. But that's one of the reasons why we're having a little bit of trouble plugging Czar into Stack, because there's a lot of overlap in, I mean, you know, Czar itself is a type of catalog in a way. It's not just a file. So those are some points, I guess.
Yeah, no, and I agree with both major points, which is, yeah, we should do this better. I mean, I think I wrote about this recently, but you know, like this sort of division between climate and imagery, I feel like has been since I started geospatial, where there are like the net CDF type people, and I didn't really understand. I mean, I originally was just vector data, so like all the raster data I didn't really understand. But you know, it seems to be like they're pretty close, but they've come up with their own solutions. And yeah, like I think I'm very optimistic on the dialogues we have going, and yeah, the overlap between that. And really the problems aren't just limited to weather or limited to satellite imagery, and that we need to have the ways those those come together. But yeah, certainly more work to be done, especially of how you represent ZAR and stack that we've taken a couple whacks at. I think the CETA guys are talking tomorrow from UK, and they've probably been some of the deepest on this as well. So yeah, I encourage you to check out that talk of kind of, they have more of the kind of weather climate data that they catalog, but they've been embracing stack and have hit challenges because it's not completely obvious which way to go. This is maybe a interesting one on machine learning applications, advantages in COG and stack and ZAR for machine learning and latency advantages to either approach.
I've only really seen COG used in machine learning applications. Can't really say much about when you might.
I mean, we use ZAR in machine learning applications every day. I mean, like, I think people are going to use the format that their data is in to do machine learning, right? Like when we're doing machine learning in the context of climate, it's netCDF or ZAR because that's where the data comes from. I personally don't think there's anything that unique about machine learning as an application that like affects the file format. Like machine learning needs clean, homogenized, well-organized data. Well, that's what I guess most analysis applications need. So I don't see it as like a very distinct use case like from other applications. But I'd be interested to hear from Henry about whether he has experience on that.
There's another question further up. Can we speak to which data formats and patterns one might use for applications for gridded data like radar, precipitation, display, flood mapping that both need to be written frequently and also displayed for visualization and light querying? I think that does sort of highlight one of the things with ZAR that I learned, which is sort of relative to COGs. Like COGs tend to always have the overviews built in, and so you can it's also not quite all the way there, but you can more likely count on that. And with ZAR, from what I understand, that's very possible. You can put the overviews in, but a lot of data doesn't have it by default. But I think the really cool thing, I think Scott will talk about this some tomorrow, and Ryan will probably mention it, but ZAR is becoming an OGC community standard, but then there's also a bunch of work on a GeoZAR spec. Maybe you can explain a bit, Ryan, between the difference between ZAR and GeoZAR and what those two things will do.
Well, GeoZAR is just kind of, I think, formalizing a lot of the things that people have been doing with ZAR. ZAR is not geo-specific as a format. It's a generic scientific data format, which is nice because then we also get add-on effect. Like there's a lot of like bioimaging people developing ZAR, and so like it's nice to leverage that community. On the other hand, it doesn't address anything like CRS or coordinates. And so there's been a couple different approaches to how people put that information into ZAR, and I think GeoZAR will just help formalize some of that stuff as like a real standard. I don't think GeoZAR itself will answer the question about what should be used for gridding data, visualizing radar data. I think in general that question gets at this challenge around ZAR, which is that like in ZAR you have complete freedom to choose your chunking strategy. Vincent in his talk today, he talked about some of the degrees of freedom you have in choosing your chunks in COG, right? And the different overviews and stuff like that. But in general, like the chunk patterns are pretty constrained in COG. They're not like varying wildly. But in ZAR, they can literally be whatever you want along any dimension of a multi-dimensional data cube. And so in that case, it really matters. And what's good for one application like backend processing might be horrible for another application like interactive visualization in the browser. I think what the solution there is we need tools like some of these serverless type things we've seen for transforming data on the fly having some of those for ZAR so that you could sort of dynamically sort of decimate a ZAR store on the fly for visualization could be super cool. So you do some of that on the back end and you don't have to send so much data to the client. There's also work going on right now in ZAR to create a 2-level hierarchy of chunking. People have brought up the fact that like ZAR chunks are very big and there could be many objects. What this two-level hierarchy is going to do is it's going to make each ZAR chunk itself have internal shards to it, or maybe I have that backwards, so that in a way that sort of subsetting within a chunk is also possible, and that could help accelerate some visualization applications using ZAR.
Yeah. I think the geos are, like you said, it kind of formalizes a lot of things that happen, but I think it can help provide clarity. And then I think it can possibly extend to more profiles to be able to say like, not only is this a GeoZAR, has this known, because like Ryan said, you can have ZAR that's not geo at all. So even just knowing this is something on Earth or this is a particular space and that's what the ZAR represents. But I think that could likely extend to even profiles where, hey, this ZAR has overviews and can be read on the web. So I think it should be a nice standardization path. And so you'd be able to look at a ZAR and see, is this a GeoZAR? Can I load this up in geo applications? And what does that say about its chunking strategy?
Yeah, I'm just reading Sean's response about ML. So pain points of COG and Stack and ZAR when using EO data and ML applications is the intrinsically sparse spatial and temporal nature of the data. So the current ecosystem of Python data focused tools, Xarray specifically, don't have good models to represent this sparse data, which can lead to scalability issues when dealing with large spatial and temporal dimension domains. Tom has been investigating other conceptual models to alleviate these scale issues with sparse data, but the community hasn't yet settled on good solutions. I thought that was pretty interesting.
I mean, I think it's important to recognize there that like all Xarray does is it takes the NetCDF data model and put it into like an in-memory data analysis API, right? So I think that question is really about like what's the data model? It's like a metadata type question. What's the data model for many images that are not necessarily aligned with each other?
Many images, what do you mean by that?
Well, I think that's what Sean has in mind with his question, right? Like, and when he mentions what Tom has been working on, right? Like that's like what level 2 data, basically. Like if you want to do some machine learning workflow, you've got like a bunch of level 2 data. They're all in different places. Like, is that sparse data? Like, I don't know if I would call that sparse data. Like each image is dense, like, right? Like it's an image. It's like a scene. What's sparse is the way that it is sort of observing the globe. Right. So sparse means very different things. Like sparse could also just mean an array where like each value is not filled in. I don't know if I think of that level 2 data. I don't know if I would describe it as sparse. I don't know, maybe I'm just.
I think that makes sense to me.
Back to Robin on the security of how we could arrange a discussion session with interested parties. I don't know. I do think I think we've made some attempts in Stack to kind of have some spin-off ones. I think we used to do a lot more of that when we were working on the core spec, and so there's reviving that. I think one of the other ideas is potentially have some Cloud-Native Geo sprint or hackathon, like we sort of, and in the past, we actually started the outreach out of some sort of sprint where you're gathering people together and having those kind of deeper discussions. And more lately, we've decided to kind of split those to say, hey, this session is just about outreach and kind of education. I think it could be cool to, in maybe a couple months, organize some sessions that are really, and yeah, could even be across the communities, but giving that sort of longer space to say, yeah, it'll probably be less people coming, but push those conversations forward. And yeah, I think the thing for me is it's just it's less fun to do that over Zoom, you know, like having these like 3 or 4 hour discussions or trying to like be present all day is just tougher than meeting in person. So maybe we can start to explore that as well. One of my favorite topics. So discussions to why the vision of stack spec to better include cloud native formats or even non-spatial tabular data, for example, documenting all the columns in the metadata. Yeah, so many people have known I've been the one that hasn't even wanted vector data into stack. And yeah, from this philosophy of like focus on a narrow problem, not try to solve everyone's problem. I do think I can try to link to some of it. Some of the work I did in my OGC visiting fellow program was to kind of figure out the right abstraction levels. And I think the key thing with vector data is that it belongs at the collection level. It doesn't really belong at the item level. And then Stack has some collection support, but OGC also has their records and catalog stuff. And so what's the sort of cloud native like bit that complements the vector data? But I think it's pretty close. I mean, I think it's something like it's like a stack collection. It's kind of a level above a stack collection in a way. And I think we just need to sort of document it. And then it likely is part of stack as well, where you can have a stack representation that works with all its tooling, but is referring to vector data. So I think it's closer for cloud native vector to have a kind of spot in the cloud native hierarchy, or it's rather the cloud native metadata that extends to all collections, not just collections that have assets of things. So yeah, I hope that one comes pretty soon. I definitely think, to me, non-spatial tabular data gives me like more pause, because I mean, it just feels like we're out of our lane and trying to solve metadata for everybody. Like, I think I would love it if Stack inherited from, you know, a temporal asset catalog or an asset catalog if there was just some JSON bit of metadata that, yeah, like, because I think that's what it is. If you have non-spatial tabular data, it's not a spatial, maybe temporal, but certainly not a spatial when you remove that. So then it's like just some fields. We have some nice fields in Stack, but then it doesn't feel like we should be the ones defining in general your link structure in JSON. So I don't know, it'd be cool to see if there's other domains that are close that we can work with. Like, I just hesitate for us to try to solve that problem. But I'm also sure that people will start to reuse those and you know, fit them into it. But I think I personally wouldn't want to standardize it until we really see like other communities that would adopt the same thing. So it's not just us in spatial in our view. Is anybody here or even online we can promote? You want to try to tackle Robin's next question about storing and tiling global high-res data sets?
Am I unmuted right now?
Yeah.
Okay, how about that? Sorry if I was making noise.
No,
I have no thoughts on the tiling thing. That is, I don't know. Rob and Matt will be back later, and they might be able to chime in on that. Yeah, and then for the jumping back just a bit to the tabular stuff, you know, we have some tabular data sets, and I think are still figuring out the right level. Catalog with Stack, and or figuring out the right level to catalog them at. We have some at the collection level, some at the item level. It was like Kurt from Earth Engine mentioned that they have vector data in Stack as well. So good time for experimentation right now, I think.
Awesome. Yeah, I'm curious. I mean, you were definitely the one that started GeoParquet and getting that conversation going. I'm curious if you're putting any data into GeoParquet yet and how that's going.
Yeah. So we've had it for a bit with a couple different data sets. The biggest one is so we have the U.S. Census 2020 data set with populations and various other things, geometries at different resolutions. So we have some GeoParquet files for that at like each census administration level, like from census blocks up to states, and everything in between. And it's working out pretty well. I think I want to say those are all collection level assets, but I could be wrong about that. I think those are all collection level assets, and they work well. One cool thing that you can do if you have items, so items linking to Parquet files or data sets, is kind of capture like the relations between them. So we have a data set from the U.S. Forest Service, the forest inventory and analysis, that's just like a dump of the database. If you read the documentation, it's like referring to whatever Oracle database or whatever that it's stored in. And you can do cool things like, so you have primary keys, and you can like capture that. And, this table, which is cataloged in the stack item, relates to this other table and this other stack item on this, primary key. You can join them on these two keys. Like you could, in theory, capture those kinds of relationships in the stack metadata. Don't know if it's useful or not, but it's a thing that could be done.
That's cool. Yeah, I'm curious, Tom, if you guys have thought about non-spatial data in Planetary Computer at all.
Everything's primarily geospatial. There's definitely like a focus on that, and then we do have like a regular Parquet file. So it just happened that the way the census block data came out was there's a Parquet data set for the population. So it has the like primary ID and then all the population fields as different columns. And then there's a separate Parquet data set for the geometries because they're released at different times was the main reason. We have some non-geospatial data, but it can always be joined to geospatial data, I guess is one way to think about it. Another interesting example, and if I can find it, I'll put it in the chat, is the NATSCO, GNATSCO, I don't know how you say it, soil database, which is a combination of both rasters and tables. And you can actually, I think I don't know exactly how it works. We have an example notebook, but I think there's like rasters that have like IDs that you can then join to rows. Each pixel would be like an ID that you can join to a row in a table somewhere to get like way more data. I'll put that in the chat.
We're gonna cube cuddle, get the and dash in namespace.
You even put lens on my computer.
Yeah. Oh, I did. That was a long time ago.
Yeah, and GBIF was mentioned. It's slightly geospatial. Latitude and longitude for some of the observations, but it's not stored as GeoParquet because that is two separate columns, two separate floats, one for latitude, one for longitude.
Cube cuddle, get deployment dash n.
It seems like GBIF sort of should be.
I think so too. Yeah. So it'd be good to connect with the data provider there, just because there's not much downside to doing it as a geometry, right? As long as you get like an efficient, way to store it. Yeah, I think that's the way to do it.
Yeah, I would go into it. Kim Robertson's been at GBIF.
Oh, I see. Okay, it's just Arterial service. No, it's cube cuddle for service / Arterial service.
Everybody mute. There's a phone caller
that. You just swap the service name in this case.
Or can an admin mute the phone caller?
Service.
Yeah, the phone caller is actually Tom, so it's background noise.
Gotcha. Cool. All right, maybe just.
Forward service. Oh yeah, there we go. That is
weird.
Yeah, PR.
I have no idea. That's I can only hear it through my headphones. It's not in my room. I don't know what's going on.
I don't think it's Tom. I think it's somebody else.
It was good. This morning I was like, this was a bad idea to come here. It was so chaotic in here. Meditate.
Okay, cool. We lost that, but then we also lost everybody.
Yeah. So now it looks like everybody's muted. Okay. Yeah, Sean was just highlighting that there's some ongoing work about creating heat maps in PG Stack that will allow for identifying data locations, which will support this problem of alternative representation for lower zoom levels. So I think that there's like so many of these questions, it's like there's research going on, but yeah, it sounds like, I think that that's something that Sean's actually working on with some of our NASA projects.
So any more questions that people want answered? If not, we can also just wrap this up early and wait for the next session. Yeah, this was definitely an experiment. I think I was imagining that more people could get on and use their microphones and contribute to the discussion than having to deem people. Looks like there's a question. Any tips for convincing climate scientists to consider ZAR when they've been happily using ideal Fortran on NetCDF3 for decades?
I think the thing that I've seen work is just, I mean, it's not easier said than done, but like show them the power of something like a ZAR plus Dask stack, and then they might be convinced to migrate their workflows if they see something that they couldn't have previously achieved before.
Do you have any specific examples of the things that have convinced people?
I think a lot of the example notebooks, I'm thinking specifically of like, Shell's notebooks demonstrating ZAR for sea surface temperature, doing like long time series analysis that she wasn't previously able to do.
That's cool.
It's pretty convincing.
Are those public? Do you want to drop some of those links?
Yeah, I can try and find those.
Let's see, any advantages to Dask plus ZAR versus Dask and COG? I do not know Dask well, so somebody.
Actually, what was it?
Any advantages to Dask plus ZAR versus Dask plus COG?
The thing that immediately comes to mind is just that you might not have to read the metadata of all the files, but if you have all the metadata stored in the stack, then you should know which files to access, and then it just really depends on what chunking and compression you're looking at.
Gotcha, cool. Mike asked, any thoughts on the alignment of the Kerchunk approach, which provides a common model and method to allow cloud optimized access to existing collections of archived data with Stack? I wonder if there's a discussion happening on that alignment. Yeah, I actually did not know much about Kerchunk before.
I can use the opportunity to plug that we're going to have a Kerchunk tutorial from Lucas Drisner in the Geoscience Information Partners Cloud Computing Cluster has a meeting on Monday, and so there's going to be a Kerchunk tutorial. I'm not sure if there's a deep dive into Kerchunk as part of this event as well, but if not, that might be a good opportunity to learn more.
Cool. All right, I'm leaning towards calling this because it's too frustrating to like see the answer, see people that have knowledge, but then have it to be, such a process to get them to be able to speak.
I think it's good to take breaks too.